Okay, so here's the last video on amines. So predict the product's form from the following reactions. If we have one equivalent of the ammonia, we can end up with having the quaternary ammonium salt with 1 methyl and 3 hydrogens on it. If we have an excess of ammonia, it's going to go to that, and then we're going to take off the extra hydrogen, so we'd get the methylamine, the carbonate, and phthalimide gives us the great nucleophile, the N-. That can do an SN2 on benzyl bromide. To give that, and then hydrazine or acid and heat cleaves out. Hydrazine is going to give us the ring system with the nitrogens, along with the benzylamine. And the important part of this is the benzylamine. Sodium borohydride and methylamine is going to be the reductive emanation, where we form, in this case, a secondary amine. Iron and HCl and nitrobenzene is going to give us aniline. It's a reducing agent. NaNO2 as a base, followed by hydrogen and platinum methanol. It's going to give us the primary amine. Remember what chapter we're in. The azide is going to give us the benzyl azide, and then we reduce that down to benzylamine, and sodium and ammonia reduce the oxime to benzylamine, Raney nickel in a triple bond, nitrile, benzylamine. There's a pattern here. OAH, benzylamine. So all we're doing is reducing the functional group down as far as we can go. On the next page, we have two reactions that rearrange in there. So what we end up with in both of these is in the end the aniline, because we'll have a rearrangement occur where we migrate to the aromatic ring over to the nitrogen. If we have two nitros, we reduce one of them cleanly to make the metanitroaniline. If we have aniline and make the diazonium salt and then replace it with whatever we have, so it's usually what's off the copper. So in this example, we put the bromine on there, and this one is going to give us the chlorine, HBF4, CuCN, acidic water. HBF4 gives us the fluoride. Ki is going to give us the iodide. This is going to give us the double bond nitrogens in between the two rings with the OH there, para to the diazo. This one's going to be the nitrogen, para to the two nitrogens. If we have the primary amine on the aromatic ring, it goes to the diazonium salt. If we have a secondary one, it stops in that mechanism we drew earlier where we end up with just nitrogen, methyl, NO, because we can't take the methyl off, so we can protonate the oxygen, draw a resonance structure, but the only way we can neutralize that is to take the hydrogen back off of the oxygen. If we have the para position open, we end up putting the NO on it if the nitrogen is a tertiary nitrogen. If the nitrogen is a tertiary nitrogen and the para position is blocked, all we can do is add it on to the nitrogen. You get the positive charge on it. And these four, if we look back at the mechanism on page 66 in video 2, near the end of the video, we go through the mechanism and you can see where it would stop depending on what we have off of the nitrogen. Okay. So here we have some mechanisms. We have the NaNO2 with HCl, so we're going to protonate the oxygen with the negative ones. We're going to protonate it again, which makes it a good leaving group off of the nitrogen, so we can send the electrons down from the oxygen to the nitrogen to form a triple bond. Okay. Now in this, you need to show the bonds in between the two so that you can see what's going on. So now we take that NO plus and react it down here with aniline. Have the aniline attack the nitrogen, so we get the NO plus on there. That gives us the nitrogen with a positive. We have water around, so remove an extra hydrogen, and that gives us the neutral compound, which we can then protonate with acidic water. Draw the resonance structure. Remove the extra hydrogen. Protonate the oxygen to make it a good leaving group. And then we can send the electrons from the one nitrogen down to form the triple bond, kicking out the water, and there we have the diazonium salt. On the next page, we can draw some resonance structures. We'll send the electrons from the nitrogen into the ring. That gives us a double bond with the nitrogen positive, negative there. Then we have the sulfonamide down there. We can put the negative charge on the 4 carbon from the NH2, so we have the 2 double bonds. Then, whoops, not yet, got ahead of the game. Negative charge with the sulfur, 2 double bonds that form the double bond, break one of the double bonds to the sulfur. Draw the other resonance structure with the double bond to the other oxygen. Oops. Lost my NH2. Then we can send it. send it down back to the ring. Then we can send it around the other side of the ring. Losing my NH2 there, and then send it back to the nitrogen to finish it off, to draw the last one. So we get the NH2, the bonds around the ring in the right spot. Then the sulfur and the NH2. So we get that. Then these, we form the alkene with the double bond there. This one goes to the more substituted side, so we get that. And then the page of amines are starting with benzene or toluene, synthesize the following compounds. So this one, obviously, we would start with toluene to make compound A. So if we start with toluene, we're going to brominate it first with bromine and iron, which would predominantly give us the parabromo, and then that we could nitrate with nitric and sulfuric acid to make the orthonitro parabromo compound. Now the next one, because in this we have the methyl on there, it's an OP director, and everything we put on it ends up orthopara to one another. In the next one, the groups are meta to one another, so we need to nitrate it. So we have a meta director on there, nitrate it again. And then reduce one with the hydrogen sulfide, ethanol, ammonia. So we get that, and then that we could with NaNO2 and HCl followed by Ki, followed by Ki, give us the iodide and the nitro. And then all we'd have to do is reduce the nitro if all we had was the hydrogen sulfide, ethanol, and ammonia. We can use it. If we had two of them, it'd only reduce one because we'd have the right amount. But if we have one, we might as well use it. That makes the aniline, substituted aniline, which we could then do with make the diazonium salt, and then add acidic water, and that would give us the compound with the iodide and the OH on there. And that's how we could do that one. Okay, so we have to be careful when we're doing these that we do them in such a way that we put the groups on so that the group that's on it directs it the way we need it to go. And there we have it. The end of Org 2. Have a great day. See you later. Bye.